Laura signs. First thing we're going to do is prove the Laura signs. Suppose you have an arbitrary triangle, ABC. ABC. Opposite angle C, you have side little c. Opposite angle B, little b. And opposite angle A, you have little a. I'm going to pick one of the three vertices, and it's random. I happen to choose vertex B. And we'll call this height H. Now we have partitioned this triangle into two smaller ones. The one to the left of this line and one to the right of this line. Now, if we consider the sine of A, we get opposite over hypotenuse. We get H over C. And if we compute the sine of C, there's angle C, we get H over the hypotenuse. Get H over A. Now, if I divide both sides on the first equation by A and both sides of the second equation by C, notice that these are equal. Well, if this equals this and it also equals that, then we can conclude that sine A over A is equal to sine B over B. Sine C over C, excuse me. Sine C over C. Notice I drew the right angle at B, and this doesn't involve B. If I had drawn the right angle at C, then I would have gotten sine of A over A is equal to sine of B over B. That is, C would not be involved. Well, once again, if this equals sine C over C, and it also equals sine B over B, then we have that all three are equal. This here is the law of sines. Now, if you have an equation like sine A over A equals sine B over B, and you know three of these four, you can find the fourth one. You can solve for it. So let us do some problems like that. Suppose you have this triangle and you come to find out, or you're given, that angle is 40 degrees, this angle is 50 degrees, 7 and x. And you're asked to find x. Now, before we go on, I just want to say one last thing. I should have said this. Now, we have these three fractions, and they're equal to one another. If two fractions are equal, 7 over 5 equals 7 over 5. Well, then their reciprocals will be equal, as long as the fractions aren't 0. If you have 0 over 2, well, that equals 0 over 5 for the record. But 2 over 0 does not equal to 5 over 0. Nonsense does not equal nonsense. But other than 0, if two fractions are equal, then their reciprocals are equal. In fact, if three fractions are equal, 1/2 is equal to 2/4 is equal to 10/20. Well, when I take their reciprocals, all three fractions equal 2. All three fractions are 2. 2 over 1 is 2. 4 divided by 2 is 2. 20 divided by 10 is also 2. They're all 2. That is, it is true that the reciprocal of each of these fractions above are also equal. Okay, so we could use those two facts to solve law or sign problems. Now, in our problem, since we want to find x, which is a side, I'll put x on the top, and then I'll divide x by its corresponding angle, sine of the angle, and we have this pair of numbers. Side over the sine of, in this case, 40 degrees. I would just multiply both sides by sine 50. I certainly would not cross multiply. There's no reason to bring this up to the numerator, only to bring it right back down. Call it half cross multiplication. Let me write it over again. Call it half cross multiplication if you like. Just bring that up. And it's allowed to be done. You get 7 times sine 50 over sine 40. This cancels out, and you have x is equal to this. X is equal to 7 sine 50 degrees over sine 40 degrees. And that's approximately, let's see, 8.3423. I worked that out. Next problem, suppose you have this obtuse triangle. That means one angle is more than 90 degrees. 120, 40, 20, 23, and x. Okay. Opposite x is 40 degrees. This angle is part of x. This angle is part of the length x. This angle is opposite it. So x over sine 40 degrees is equal to 23 divided by the sine of the angle opposite it. Okay. Now, just bring up the sine 40. Just half cross multiplication. X is 23 sine of 40 degrees over the sine 20. And again, when we don't do things blindly like cross multiplication, why does it work? This cancels out. This stays. If you want to put over 1, fine. 23 times sine 40 is just what I have on top. Sine 120, or sine 20 times 1, is what I have in the denominator. And it turns out that this is approximately 13.1557. Let us try another one. Suppose you have 8, 50 degrees, 70 degrees, and x. Now, it's always best not to use something that you calculated. For example, in the last problem, we calculated x. Maybe we made a mistake. So it's best not to use x. In other words, if I ask you what y is equal to, you have y and 20, and you have x and, you have 40, and now you have x. Maybe you made a mistake with x. I'd use the pair that they gave us. I would say 23 over sine 120 is equal to y over sine 20. And of course, just bring the sign up there. That's how I would find y. You can use x, but if you made it, so in other words, let's see what you would do. You have y divided by the sine of the angle next to it, opposite it, is equal to x, 13.157, divided by the sine opposite it. Couple of things. One, this probably went on further, so you're approximating already, and maybe we made a silly mistake. Maybe our calculator was in radians. Maybe when you saw a degree here, you thought that was another 0, and you wrote sine of 400 degrees. People make mistakes. I know I surely do. Try not to use information that you calculated. Try not to. Sometimes you don't have a choice. In this problem, well, we have x and the angle next to it, or opposite it, so we have that pair with one unknown. But we have this side, but we don't have the angle opposite it. We have this angle, but we don't have the side opposite it. But we can find this angle. 50 plus 70, that's 120. But that's supposed to add up to, the three angles should add up to 180. Well, 0 plus 0 gives me 0. 2 plus 6 gives me 8. The 1 I already have. So that's what the third angle should be. Of course, you could have done 180 minus 120 and also gotten 60. In this case, we had to do this. So our other pair is 8 divided by the sine of the angle opposite it. So x, just bring that up there. X is 8 sine 70 degrees divided by 60 degrees. Sine 60 degrees. And that would be your answer to x. How much is x equal? Approximately 8.6805 units, whatever the units happen to be. Suppose you have this triangle. This is angle x, this is 2, this is 30, and this is 1. Okay. So you have that pair with one unknown x, which is good because you want to find x, sine of x over 1, and then you have that pair where you have everything. It's the sine of 30 over 2. Well, sine x over 1 is just sine x. And it equals to this. This is a number. You take, because sine of 30 degrees is a number, divided by 2, get another number. Sine of x is a number. If you interchange, and x is an angle, if you interchange those two, you are allowed to do that. As long as you say inverse. And if you interchange it again, sine of x is equal to sine of 30 over 2. Since it does say inverse, don't say inverse right here. That is, it's just that. No circle there either. Just got back the line above. Okay. And if you're in degree mode and you put this into your calculator, you would conclude that x is approximately 14.475 degrees. And of course, that's that problem. Let us try the next one. always try not to use information that you calculated to do the next problem, if there is a second problem. Now here, we have one pair, the angle and the side opposite it. And here we have the unknown angle and the side opposite it. So there's 3 of the 4, piece of cake. It's sine of x divided by 7 equals the sine of 40 divided by 12. The piece of cake was writing this equation. Now bring the 7 up. 7 sine 40 over 2. Now you can interchange those two. It has to be the sine or cosine or tangent, etc. of one thing equaling something else. No 3 times, no 3 plus. Sine of one thing equals something else. If you had a 3 over here, divide both sides by 3. So the sine of one thing equals another. You can switch those. Sine of y over 3 equals x. We change that sign to sine inverse. Sine of 7 sine 40 over 2, that's x. But don't forget inverse. And it turns out that that's approximately 22.0243. 0243. Suppose they tell you that angle A is 50 degrees. Angle A is 50 degrees. Angle B is 68 degrees. And little c is 230. And they asked you to find little a, little b, and big C. So we draw a triangle. A, B, C. A is 50. B is 68. Little c, which is opposite big C, is 230. Now, nobody really should take out any kind of instruments and say, you know what, this angle you wrote 50 and that's 68, but the 50 looks bigger than the 68. It doesn't matter. At least it shouldn't. Okay, so we need to find little a, little b, and say also little c. Okay. Now, when it comes to finding little a, we have our pair where only one is unknown. But there's no other pair. The only other thing they gave us was little c. Well, is there a way to find big C? The answer is yes. 50 plus 68 plus angle C, when you add them, you should get 180. Well, these add up to 8 plus 2 more gives me my 0 carry. So far we get 12. Add 6 more to get 18. That's angle C. That's what you add. So all 3 angles add up to 180. Okay. So we have big C. It's 62 degrees. And we have little c, which is 230. So what's little a? Well, little a divided by the sign opposite little a. Well, now I'm going to use little c, which they gave me, and I have no choice but to use sinus 62 degrees, where I figured out 68 degrees. This just goes up there. A is equal to 230 sine of 50 degrees divided by the sine of 62 degrees. And if you crank out these numbers, you get that A is fairly close to 200. Okay. So now let's find little b. We don't have little b, and we do have the sine of big B, or we do have big B. Now, don't use, this was much, first of all, we got A by using sinus 62 degrees. We could have made a mistake here. We could have made a mistake getting the 62 degrees. A has a much higher chance of being wrong than C. C has less chance of being wrong. So let us use C. So we have little c, and we divide by sine of 62 degrees. This goes up there. Half cross multiplication. B is 230 times the sine of 68 degrees divided by the sine of 62 degrees, and this turns out to be 241.5232. Okay, so we found A, it's below. We found B, and big C and little c we found, which is excellent. Now, suppose you're given this triangle. It's labeled 100 degrees at C. B is 10 degrees. Little c is 115. Opposite angle A is little a. Opposite angle B is big B. Little b. They want us to find little a, little b, and capital A. Everything. Well, we have one pair. That's for sure. That can't be wrong. And we have another pair where only b is unknown, little b. So I'll put the unknown on top. Little b divided by the sine of b is equal to little c divided by the sine of c. This goes up there. So little b is 115 sine of 10 degrees divided by the sine of 100 degrees. .2776. So we have B. Now we want A. Well, we're in trouble. We don't know little a or big A. But we know two of the three angles. The third one we don't know. And we know one thing. They have to add up to 180. 0 plus 0 plus what gives me 0? 0. 1 plus 1 is 2, plus 6 more gives me 8, and the 1 gives me the 1. So, 60 degrees. And you can check. Okay, so I wrote down 110 for the first angle. I already added in my head, sorry. You have 100 plus 10 plus an unknown that add up to 180. Again, 0 plus 0 plus 0 gives me 0. 0 plus 1 is 1, so you need 7 to get 8. And the 1 is the 1. So that's the angle. It's not 60, it is 70. Okay. And you can check. 10 plus 70, 70 plus 10 is 80. Add 100 to it, get 180. Now, that's pretty much correct to me. So A divided by sine of A is equal to little c divided by the sine of c. Just bring this up here. And now you have what A equals. A is approximately 109.7317. So, we just calculated little a and a moment ago, big A. There is big A. So, that problem is done. Suppose you have this. Little a is 28, little b is 15, and big A is 110. So, we want big B, big C, so we have all the angles. We have little a and little b, so we need little c. Okay. This is given. The rest we need to compute. So one angle is bigger than 90 degrees. So there's our triangle. This is angle A. It is 110 degrees. The side opposite it is 28. So I use these two pieces and we'll call this B. Opposite little angle B is little b, which is 15. I get that's C. So that's A. This is B. C is unknown. So we need to find a pair that we have. Here's a pair that we have. And the only other thing we have is little b. So that's going to pair up with angle B where we don't know angle B. That is the sine of B, which we're going to figure out, divided by little b is equal to the sine of A divided by little a. So half cross multiplication. This gives us 15 sine 110 over 28. Now I said we're going to find the sine of B. You don't have to. In fact, you really shouldn't. You could interchange those two. B is equal to the sine of 15 sine 110 over 28. But we have to put inverse. And turns out that this is approximately 30.2252 degrees. So we now have B. We have angle B. We don't have little c. We don't have big C. We don't have either of these. And we can't find little c, but we can find big C. If you're given two of the three angles of a triangle, you can find the other. One angle was 110 degrees. The other one is 30.2252 degrees. The third one, we don't know. It's going to be a decimal, and it's going to add up to 180.0000. 180. Well, 2 plus 8 gives me 0 and carry the 1. This column is 6. I add 4 more, I get 10. Bring down the 0, carry the 1. This column is 3. I add 7, I get 10, carry the 1. This column right now is 3. I add 7, I get 10, carry the 1. This adds up to 1, so I add 9, I get 10, carry the 1. This adds up to 5, I add 3, I get 8. And the 1 is that 1. So it looks like that's the other angle. $39.7748. $39.7748. $39.7748. Of course, you could have added the two angles together that we had. We would have gotten 140.2252, and you subtract that number from 180, put some zeros in, borrow, 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 borrow again, borrow one more time. 10 minus 2 is 8, 9 minus 5 is 4, 9 minus 2 is 7, 9 minus 2 is 7, 9 minus 0 is 9, 7 minus 3 is 4. Same answer. Same answer. Okay. That's up to you how you do your arithmetic. But we have the three angles, 30.2252. Now, we need to find little c. There's really no choice but to use big C. So, it's going to be the sine of big C, or little c, divided by the sine of big C. And hopefully we didn't make an error finding big C. Divided by, now I can use b divided by little b, sine of b divided by little b, or little b divided by sine b, whichever I need. But maybe I made a mistake finding capital B. I'll use the information they gave us. 28 divided by sine of 110. Just bring that up. So C is 28 times the sine of 39.7748 divided by the sine of 110. And it turns out that that's approximately 19.0633. Now, I want to draw this triangle. We have 110 degrees here. That was A. I call that angle C, and this angle B. And little a was 28, and little b was 15. And we found out that little c was 19.0633, and what's angle B? 30.2252. And the other one is 140, so it must be 39.7748. the angles from increasing to decreasing, from highest to lowest, angle A, angle C, and then angle B. It should be the same for the sides. Opposite A, opposite C, and opposite B. These angles were going down, the length should be going down. That is, angle A is bigger than angle C, which is bigger than angle B, and 28 is bigger than 19, which is bigger than 15. It's somewhat of a check. If instead for B you got 21, something is wrong. Angle C is bigger than angle B. That means the side opposite angle C, called little b, should be bigger than what's opposite little b. And 19 is not bigger than 21. Okay? But it wasn't that. It was 15, and it matched. Nobody guarantees you that it's right. But if you got 21, I guarantee you that it's wrong.